trunnion is splined to the drive shaft. The hub is clocked 45 degrees on the trunnion. So instead of just tilting straight in or out, this has the effect of gradually increasing blade pitch with more hub tilt. It can be a little hard to see the tilting and pitching happening as one movement, but if we fly around to the blade tip, notice how the arrow and blade profile points a little more to the left or right with hub tilt. If we move the foot pedals to pitch the blades, notice how this hub flapping still works to add or subtract pitch. So, if there's more air pressing against the bottom blade than the top, the inequality will cause the hub to tilt, adjusting blade angles accordingly. Now, the bottom cuts a little less into the air, making less thrust, while the top pitches a little more. Pitch links are attached with spherical bearings so the rotor can still flap, even as pitch commands come through. Each blade has counterweights front and back and lengthwise at the hub for smooth operation. And here's the tail rotor in action, keeping the helicopter aligned with dependable directional control. Now that we've seen the inner workings of propulsion and flight control, let's head back over to the cockpit and see what the pilot sees when flying the helicopter. Starting with the dashboard and displays. Newer helicopter models use digital displays for most things. Past versions of this same model had 30+ warning lights along the top, and 16 or more round gauges and flight instruments in the main dash area. These screens have a seemingly endless array of panels and options. The current view is what a pilot might have active at times during a flight. Let's look at a few notable instruments here. On the right, or primary flight display, we see radio frequencies at the top, both for navigation and communication.